So let's have a quick recap of equations and inequations. Of course, all you're really doing when you're solving an equation, another way we phrase the question sometimes is where instead of calling it an equation, we call it a formula. And then we say make a particular pronumeral the subject of the formula. But it's all really the same thing. Now, not the most difficult equation, I know. In fact, you've been doing equations and algebra before you even knew you were doing algebra and equations. You remember back in primary or maybe even infants, we used pronumerals back then. We didn't call them pronumerals. They didn't look like pronumerals. They usually looked like shapes. You remember where they said square plus 3 equals 6? What goes in the square? Technically, when you think about it, that's algebra. You're just using a square to represent an unknown. Anyway, the reason I bring this example up is, I guess, the thought process. Some people think of it like, well, whatever you do to one side, you must do to the other. And then you must do the opposite. And that's why a lot of people are talking. I think of it a little bit differently. I think of it like actually physically moving the terms. And I know that whenever I move something across that equals sign, I've got to change its sign. So I would look at that and think, okay, I'm going to move that 3 over to the other side. So what I'm really looking at is x equals 6 minus 3. I probably wouldn't write x equals 6 minus 3 down, but well, that's what I'm thinking when I see that equation. And obviously x equals 3 is the answer. 5z equals 45. I suppose when it comes to multiplication and division, that is one where we're thinking do the opposite, or the more correct mathematical term is not do the opposite operation, but do the inverse operation. And so the inverse of multiplication is division, but we don't go divided by, we set it up like a fraction. It's like I was saying the other day, fractions are division, and so we write it like that because it solves our problem straight away. Now, all right, the fraction may or may not cancel. In this case, it does. But if it doesn't, I've got my answer. In this case, it does. Z equals 9. Then we've got these sort of equations where we got a choice. Some people like to expand out first. Some people like to do the division first. What did I do? I expanded out. Of course, it doesn't matter which order you do it in. We're just trying to find out the value. So I want to move that negative 20 to the other side. So I'm adding over there. So it's really 4a 36. Do our division. There's 9. Then we progressed and got really tricky. Oh no, pronumerals on both sides of the equation? How the heck am I going to cope with this? But then again, if I look at it and think, oh, well, I'm just going to move the 2 over there. I just want everything with a pronumeral on the same side, so the z's coming to the left. So really, that is the equation, 2z's negative 11. Bingo, there's the answer. Oh no, pronumerals on the bottom of the fraction? How the heck am I going to cope with this? So every time we sort of upped the ante and made them look a little bit harder. But they're still all the same idea. Fractions, well, we just try and get rid of the fractions, multiply by the common denominator. In this case, it would be 7y we're multiplying by, so 5 plus 14 is 21y. There's our answer. Yes, I put this one in here. The old fraction equals a fraction. And of course, the quickest way of doing that equation, cross multiply. So whenever you've got fraction equal fraction, you just multiply along the crosses. So that becomes 3x plus 9 is 10x minus 30. And then we move some terms around and get our answer. All right, well, let's talk more about inequalities and inequations. We change the inequality sign. There's 2 situations that we do it. If you multiply or divide by a negative number, the way I think about that, if you change the sign, you change the sign. If you change the sign, you change the sign. So if I'm changing the sign of the pronumeral, I'm also going to change the inequality sign. You change the sign, you change the sign. The other time, which is it's a lot rarer, but it's when you're doing reciprocals. Now it is rare you get this one, but you know, if you have it, because we know that 2 is I was going to say greater than, 2 is less than 3. But if I was to turn both sides upside down, it's no longer true. A half is not less than a third. So if you take reciprocals of both sides, you would also have to change the inequality sign. That's a little bit rarer, as I say. Again, a very simplistic one. Other than that, it's exactly the same, of course, as solving equations. There it is, x is less than 6. But that now brings me to how we would plot this sort of thing on a number line. And you've probably been told different things over the years, and I'm probably going to tell you something different again. The way I like to do it, well, the answer, of course, we have to highlight what it is. And it's just like regions in the plane, it is no different. If the boundary is included, we colour it in. Or we make it a solid line in the case of regions in the plane. In this case, the boundary is not included, so I leave it as a circle. And then we simply draw an arrow to indicate where we are. Now, I know there are some teachers who would have said to you, what I've just done is bad, because they like to see the line on the number line itself. I personally don't do that, because sometimes you can lose it depending on what colour ink you're using and things like that. You can lose it on there. I draw mine just slightly above. Whilst we don't have more than one equals sign on the same line when we're playing with equations, it's not true when we start talking about inequations, because it is possible that something could be between two things. But the rules, again, are still the same. Although if you're thinking in that idea of what you do to one side, you must do to the other, now we're sort of saying what you do to one thing, you must do to everything. So in this one, I'm going to move the 6. So I'm taking 6 away, but I'm going to move it to both sides there. So it's -4 and 8. Now I'm going to divide by -4, but of course, if you change the sign, you change the sign. And that's where some people will stop. I don't know about you, but I'm feeling really uncomfortable right now. Like, to me, my little head's going, no, but no. Just fix that up, okay? Because to me, when I write my solution down, it looks like the number line. Like -2 is on the left of 1. -2 is not on the right of 1. That's just unnatural. It doesn't happen. Because I believe these things actually exist out there. And if I was to find them out in nature, -2 would be on the left of 1. And it just looks so much nicer. I'm sure you agree. And on the number line, how would we do it? In this case, I would colour the boundaries in because they're included. In this case, I'm saying, hey, we're in between the two. So that now brings to the correct, i.e. Mr. Simmons is fussy, way of writing inequalities. So we have this one. This would be x is greater than 5. It is not 5 is less than x. Okay? Why? Because when you're solving it, the question basically is saying, what is x? And the answer is, x is greater than 5. If you say to me, 5 is less than x, I go, well, that's fantastic, but what's x? You're not telling me what x is, you're telling me what 5 is. Yes, I'm fussy. So x is greater than 5 solves the problem. Well, I suppose technically 5 is less than x is correct. It's just ugly. Okay. Something like this one. I would write it like so. It looks like the picture. 4 is on the left-hand side, 6 is on the right-hand side, and we're in between. I've seen all sorts of interesting and weird ways people write this one. I hate that one. Yuck. 6 is not on the left of 4. 4 is on the left of 6. Oh, definitely not. Because that one, that second one, is actually wrong mathematically anyway. Why? That's it. It's that one word right there. The word or. X is greater than 4 or x is less than or equal to 6. Okay, I'll make it 1,000. That satisfies that. Because you're saying it's one or the other. No, it's not one or the other. It's both. if we were to write it as two separate inequalities for some insane reason, then the correct word there would be and, not or. So that is just plain wrong. Okay. Then we have this situation where we're on the outside of the two boundaries. Again, it looks like the picture. There's the 4, it's on the left-hand side of 6, but look at the inequality signs. They're pointing in the same directions as the arrows. See, maths can be a beautiful thing if you try. Just make it look nice. I don't like that. I know it says exactly the same thing, but look, it doesn't look like the picture. Sort of like gone backwards and yuck, horrible. No. No, again, this is not correct. That is not saying what we want it to say. That technically is saying and, but in this case, it is an or situation. Find something that is both less than 4 and greater than 6. Well, you can't do it. So, no, that's just plain wrong. All right, there's our first exercise of the day.